So our learning target is that students will be able to graph the number E, although it looks like a letter, it's a number, and use it in real life examples. So let's talk about what the number E is. We call it a natural base E. Okay? The number E is called a Euler number, and that's because Euler is the person who developed this irrational number. So if you find this on your calculator, type it in. If you've got a small calculator and you hit it, it's above the ln button. So you'll have to hit second ln. When it does that, it kind of does this. It's waiting for you to give the exponent. So if you look at this, there is no exponent attached to E, so that's an imaginary 1. So plug in 1, and it should give you this number. The graphing calculators have two buttons. They have the same E raised to the X, and they just have a normal E as well. Their normal E is above the division symbol, so you can just do regular E when it's raised to power 1, or you can use a different button when it's a different power. So I want you to find that button on the calculator. So it's very similar to pi in the respects that you're not going to be expected to know this whole number. You're going to use the button on the calculator. But if I wanted you to simplify problems that involved E, we would go back to our exponent rules that we learned back in chapter 5. So the bases are the same. It's a multiplication problem. What do we do with these? We add them. So it becomes E to the 7th. Okay, same idea here. These are not exponents, so we just do these like a normal problem. So 25 divided by 5 is 5. But then on the E's, if you look at here, the basis stays the same, and we do what with these? We subtract them. And then there's nothing on the denominator. Okay, 6e to the 4th squared is like 6e to the 4th times 6e to the 4th, which is 6 times 6. And then e to the 4th and e to the 4th, what again we do? We add these. Now, one of the exponent rules had said if it's all multiplication inside, we can just distribute that power to everything. So 6 squared is 36. Then e to the 4th squared, power to a power, we multiply. And notice we get the same answer. So now we're going to transition into graphing these. So when I give you this natural base function, which means there's an e involved, it's very similar to the y equals a times b to the x. So the difference here is right in here. So what you're going to be looking for, again, is what kind of number will this end up being? Is it going to end up being a growth, or is it going to end up being a decay? And you'll find that out once you actually simplify e to the r. So here is what we're going to look at. Okay, is e squared bigger than 1? Or is it between 0 and 1? Remember, e is 2 point something, and if you square it, you're over 4 point something, so you know it's bigger than 1. So we know that this is going to be a growth. And I would recommend you think about that first before you graph, because if your graph doesn't match what it's supposed to look like, you probably typed something in the calculator wrong. Other than that, it's no different. So we're going to go -2, -1, 0, 1, 2. And then let's see how it ends up. So when you go to plug these in, you're going to go 2.5. Hit the E button, raise up to the power of 2 times, and then you're going to throw this x in. And so the next one's going to be 2.5, E raise up to the 2 times -1, etc. So I went ahead and did that on my calculator, and I got this. Alright, already I'm probably not going to want to graph 18.5, and these are getting bigger and bigger, so I'm not going to want to go that route. Let's go smaller. So 0, -1, -2, let's try -3 and -4. -3 is about 0.0062, that's pretty small. Let's go some decimals. How about -1.5? And -0.5 would give me about 0.92. Alright, so let's graph these. So -0.5 is over here to the left, and then up almost 1. And then -1.5, left 1.5, up 0.13, that's not very big. -2 is at 0.04, it's even smaller. 0 is at 2.5. So you're seeing what's going to happen is we're going to level off real close here, and then we're going to shoot up. So that goes along with the fact earlier that we said that this would be growth. And just like with every other graphing problem, you're going to have to come up with the intercept and the asymptote. And you're going to have to do that on your quizzes and tests as well. So your intercept is right here where it's hitting the y-axis. So we're going to call that 0, 2.5. And then your asymptote, remember, is a horizontal line that your graph comes really, really close to touching and kind of levels off next to it, but never actually touches it. And that is, again, your x-axis. But the equation for that is going to be the line y = 0 because it is a horizontal line. Now, continuously compounded interest is kind of similar to the compounded interest, except for continuously means it's non-stop. It just keeps going and keeps going and keeps going. It's at a faster rate. So continuously compounded interest is interest upon interest, quicker and quicker. And we call this the PERT formula. And the reason we call it the PERT formula is if you look at it, P-E-R-T, PERT. So this again is your amount at the end that we're looking for. This is your principal amount. I don't know, I think it might be LE. I can't remember. But it's what you start with. E is E. We don't plug anything in for E. E is E on the calculator. And then, of course, your R is the same as it's always been, so is your T. T is your years. And your R is your percentage switched to a decimal. So let's look at this problem here, and we're going to use the PERT formula. Remember that these are exponents and they're multiplied together. So we're starting with 2800 E, and this says 0.29%. I gave you this one for a reason because some people think that because it's already a decimal that they just put this number here. No. You still need to get rid of that percentage by dividing this by 100. So it's going to be 0.0029. Then we're timesing that by years. Now we can plug this in. And our total amount at the end will be $3,010.54. Now, if you can't type it in all at once, you're going to have to do this first. So this is the long way. So let's do this right here. And then you want to do the exponents. And then you'll get 2800 times 1.075192806, and on and on and on. And then times that by 2800. And then you get the same answer. Again, some of your calculators you'll be able to type this right in the way it looks.